Welcome to the deep dive. We love sifting through fascinating sources here, really digging for those insights that matter. And today, well, we're tackling maybe the biggest quest of all, humanity trying to understand the universe itself. Our guide for this is the incredible work of Dr. Brian Keating. He's a cosmologist, professor at UC San Diego. And what he does so well is blend those, old historical observations with really cutting edge modern astrophysics. So our mission today, let's try to unpack how our picture of the cosmos has evolved from people just gazing up at the sky centuries ago to the really advanced science we have now. We'll look at the tools, some of the, missteps along the way, and of course the huge discoveries that changed everything.
Exactly. And I think what's so compelling about following Dr. Keating's perspective here is that it's not just a history lesson. It's not just facts and dates. It really gets into the nature of science itself. How progress actually happens, that constant back and forth between intuition, like a hunch, and the hard data. And importantly, how we challenge what we think we already know. He even kicks things off with this great thought experiment. Imagine Einstein in, 1914. If he'd had some super powerful AI, could it have figured out general relativity just by crunching the numbers of Mercury's orbit? It immediately throws you into this mix of cosmology, history, philosophy. It really highlights that human spark. You can't just get there with data alone, it seems.
Yeah, that Einstein question, it really does make you stop and think, doesn't it? It kind of underscores how much scientific leaps forward depend on those moments of just human insight. And Dr. Keating himself, his own work involves building these incredibly sensitive instruments. They're designed to measure the faint polarization of the cosmic microwave background, which is basically the oldest light in the universe, right?
Yes.
Afterglow of the Big Bang, our first sort of baby picture of the cosmos. But, and this is the connection, he draws a direct line from that work all the way back to Galileo, back to his telescope in 17th century Italy.
Right. And that connection, it really gets at a fundamental question. How do we even start to measure something like the cosmic microwave background? Something so vast, so ancient? Well, we wouldn't, not without the groundwork laid centuries ago. It shows how science builds, incrementally, layer upon layer, often starting with those maybe more intuitive first steps. Keating even talks about his personal connection to the moon. He calls it his favorite object. Apparently, he was seeing the moon that got him started. And fun fact, it's the only celestial body you can see all year round from the South Pole, where some key experiments happen. So it bridges that personal fascination with the really rigorous science.
That's interesting. And thinking about Galileo looking at the moon, Dr. Keating points out something fascinating about Galileo's famous sketches. We think of them as groundbreaking, and they were, but Keating calls them artistic yet scientifically flawed. But here's the insightful bit, I think. Galileo wasn't just trying to draw what he saw, the geometry of it. He was trying to capture the feeling, the experience of seeing the moon through this new device, sort of bridging human perception with this emerging idea of objective measurement.
That's a really subtle but important point.
Yeah, and even the word geometry, its roots mean earth measurement. It shows how these early scientific tools started locally, practically, measuring fields, building things, and then we scaled them up, way up, to calculate the moon's distance, how high its mountains were, and eventually the structure of the whole solar system.
Absolutely. And, we have to remember the path wasn't smooth. It wasn't just one success after another. The missteps, the wrong turns, they're often just as important for learning. Think about Aristotle, right?
Yeah.
Hugely influential, but he thought heavier objects fall faster. Just seemed intuitive.
Yeah, seems logical on the surface.
It does. Until Galileo came along with his experiments, actually rolling balls down ramps, timing things, measuring. He showed Aristotle was wrong. And that wasn't just correcting one fact. It was a shift in method. Rely on observation, on data. And that connects to figuring out depth perception in space. For a long time, people thought comets were just weather phenomena like clouds.
Right, just things happening in our atmosphere.
Exactly. Until astronomers could use parallax, looking at the comet from two different places and seeing how its position shifted against the background stars. That proved they were much, much further away. Parallax became crucial for gauging cosmic distances.
Okay, so measuring distances. That brings us to another huge step, right? Proving the Earth moves. Not just that it's round, but that it's actually orbiting the sun. That must have been a monumental shift. It totally redefined our place in everything. And that wasn't really nailed down until, the 18th, 19th centuries?
That's right, with stellar parallax. Using the same principle, but looking at stars.
Ah, so as the Earth moves in its orbit, nearby stars should appear to shade slightly against the very distant background stars.
Precisely. It took incredibly precise measurements, measurements that were only possible with better telescopes, but they finally did it. It gave us the first reliable way to measure the immense distances to stars. It blew the scale of the known universe wide open.
It really did. And the telescope technology itself, that precision, it shifted astronomy. It went from being maybe more philosophical or theoretical to being driven by hard empirical data. Measurement became king.
And it's interesting, the telescope itself, Keating notes, it has Dutch origins. Its invention and refinement weren't just happening in a scientific vacuum. It was tied up with trade, with craftsmanship, lens grinding, even early capitalism, you could argue.
So scientific progress isn't separate from society, it's embedded in it.
Deeply embedded, pushed along by economic forces, cultural priorities, and beyond just the tech, our whole way of thinking about the universe was changing too, philosophically. Like the philosopher Spinoza, who influenced Einstein quite a bit, his idea of pantheism.
Where God isn't some separate creator, but is the universe, the inherent order and beauty in nature itself.
Exactly. That kind of thinking also shapes how scientists approach their work, the kinds of questions they ask, the sense of awe they feel.
You know, what really stands out to me from all this is that the journey isn't simple. It's not just point A to point B getting smarter. It's this really rich, complex story. Evolving tools, sure, but also sheer persistence in observing. And importantly, accepting those conceptual wrong turns, because even they seem to push us towards a deeper understanding somehow.
Precisely. It puts everything in a larger context. You see
Yeah.
how knowledge actually gets built bit by bit.
Through observation, yeah, but also through analysis, through critical thinking, through challenging assumptions. And those big breakthroughs, they so often seem to come from that mix, don't they? Human intuition, that willingness to guess or to be wrong, combined with incredibly precise measurement. It really makes you wonder, doesn't it? I mean, we've gone from Galileo sketching the moon by hand, dealing with flaws in interpretation, to these amazing instruments today that are measuring the faint echoes of the Big Bang across the entire sky. It's clear that understanding the universe is about persistence, yes, and better tools, definitely, but also that willingness to say, okay, maybe we had that wrong. Let's rethink, correcting our own ideas. So, thinking ahead, what kind of new intuitive leaps might be needed now for the next big breakthroughs, especially, with AI getting so powerful? How does that balance change between that unique human insight and what technology can do? How will that partnership or maybe tension shape our next picture of the cosmos? Something for you to think about. Based on this journey, what future questions about the universe really grab your curiosity?